Hi, everybody. Welcome. We all know the drill by now. This is one of our regular quarterly updates, all about the new features that have come in App Connect Enterprise 13. The latest one of those mod releases that we'll be talking about today is 13.0.7.0. And as usual, we're going to cover the major new features in the release. We're also going to spend around about half of our total time together looking at some demos that have got some pre-recorded audio commentary by my good self going over them. So we're going to keep going into and out of those demos as we go through. Most of the topics I will talk through in advance, so you'll know what to expect from the demo, and then you'll come back to me for some further live commentary after each one. Today's agenda is going to cover two major things. Most of our time will be spent on software features, but of course we also have our container offering. Sometimes we get confused between containers and software. We can use the names interchangeably sometimes. As part of our container offering, we have an operator and we also have some images. And I want to spend one chart, given some latest advances in that area, talking through that latest container release. And then we'll spend the majority of our time on the software. For the software piece, we've got 4 separate demonstrations. They range in time from about 5 minutes through to about 8 minutes. And we will talk through all of the features that you can see on the chart here. So without stealing the thunder of any particular feature and diving into it here, let us just crack straight along and start talking about async containers and the operator 13.0.0. This is a little bit of a departure from what we've done previously in the area of containers, in that we've now got this latest operator release, which comes with a 3-year support window. Previously, we've separated our container releases into a continuous delivery stream and a longer-term support stream that we've called a variety of different names over the years. SC2 at one point was its name. This latest release, the Service Cycle 3 release, basically means that you have that full 3 years worth of support, and it aligns quite nicely with the version 13 of the product. So we'll have a little bit of overlap with earlier V12 releases around about 6 months. There's a fantastic blog out there that's been written by Rob Convery that goes into more detail across all of these features. But I'm going to pick out on just a select few of them today. So we've got a new enterprise agent, a chat experience that is based on top of some LLM capability, some AI capability that enables us to answer questions about what you've got deployed in containers. We're going to be talking about MCP quite a lot today, but we're not going to be focusing on the agent today. So I'll skip over the connectors as MCP items. The next one down that we've got on the bulleted list here is talking about dynamic CPU allocation for faster startup. This is actually a really powerful new capability that comes along essentially to increase the performance of ACE so that it starts up quicker, but without actually increasing any of your licensing costs. So this feature allows you to allocate higher CPU resources during the startup phase of a container and then dynamically reduce them down to lower values for when you're actually running at a constant rate later during the licensed phase. And this particular feature, it builds on top of a capability of Kubernetes called in-place pod resizing. And that feature was originally beta in Kubernetes 1.33, and it's been recently become GA in Kubernetes 1.35. And it's going to be enabled by default on most Kubernetes distributions. So it's available to you if you're running as part of an OpenShift deployment, if you're running as part of IBM Public Cloud on Azure, AWS. And it's also available in the latest OpenShift release. So in 4.22, that beta feature actually becomes generally available. That's due any day now in the early May sort of timeframe. So a really good opportunity here to get some better performance without having to pay for higher CPU usage during that startup phase of the container. What else have we got here? So we mentioned the fact that we've got the ability to configure different Java versions as part of your custom resource. So we support 1.8 and Java 17. We'll be talking quite a lot about Java 17 later on today. So that can all be configured in the container as well. We've got the ability to configure tolerations and node selectors, which are essentially a Kubernetes scheduling mechanism that helps you determine which particular physical nodes a pod can run on. So that's a good way of pinpointing particular workload to particular physical resources. And the last item that's on this chart is all about reducing the number of containers that are needed for designer authoring. For a long time now, we've had this ability to examine a broker archive file and then determine the most optimal way of then executing the flows that we find inside that bar file. And what we're going to do here is, as I say, in this release, we've also examined the number of particular containers that are needed for certain purposes, specifically around the area of supporting designer authoring. So reducing down those number of containers that are needed to make things so much more efficient. So that's a good summary of the ACE in Container Operator Release 13.0.0. We're going to move on in the interest of time. And the other features that we cover in the software space today are all listed out on this chart. So if anybody fancies a snooze through the rest of today's presentation, you have a good, efficient summary of everything that I'll be talking about on this page here. Of course, we're going to dive into each of these topics in more detail. So with that thought in mind, I won't dally too long here, other than to say that the first thing that we're going to focus on are some of our capabilities in the area of artificial intelligence. As you might imagine, these days, most product releases have something to say about AI. And in particular, in this release, ACE focuses on some capabilities that we've got in the area of MCP servers. We've summarized the whole of the ACE current landscape of AI features on this chart, but we're going to zone in our commentary on the two items that have got the MCP icon against them in the middle of the chart here. And this enables us to provide some tools that are available for users to essentially expose features of ACE as MCP tools. In order to do this, we might first of all want to make a few comments about what MCP actually is. It's a standardized method that can be used for connecting AI-driven applications to other third-party external systems. So it's been built on a couple of other existing standards. It uses JSON RPC under the covers. It also enables you to use streamable HTTP as a transport layer. And sometimes people sort of grapple for that one-sentence summary of what it does. And you can think of it a little bit like a USB-C port for AI applications. It's a one-size-fits-all way of quickly exposing things in a format and a protocol in which an AI application would naturally understand it. So that means when you're writing these applications, and whether you're using IBM's Watson XAI technology or some other third-party chat assistant like Claude or ChatGPT or whoever it might be, it enables you to get access to a wider range of systems. And with that in mind, ACE has access to a lot of systems, a huge range of third-party systems, and we're trying to unlock that power when we're exposing our own MCP tools. And we've done that in a couple of ways to start with. One of those ways is to expose existing connectors to third-party SaaS applications. So that's come along as part of our container release, and it's shown using the top example in this chart that demonstrates an integration server, allowing tools to be exposed and listed and then invoked at runtime as well. So in this particular case, we've got an example with Salesforce and AWS, and we've got a plethora of those applications. You can see the number that's written on the chart here, 2,800 or more connector object and action combinations that are available. So this is a really powerful way of unlocking all of those existing capabilities. The other item that's shown here is exposing existing REST APIs as MCP tools. So if you've already deployed REST APIs into an ACE integration server, you might want to expose those as MCP tools as well. Today isn't really a futures presentation, but just a nod and a wink to what might come later. We're considering expanding what we're doing with MCP tools to also incorporate something in the authoring experience. So maybe when you're creating a Toolkit message flow, for example, being able to drag and drop an MCP input or an MCP reply node into a message flow and therefore expose its capability over MCP. We think that's another natural use case we might go after in future. In a similar way, there might also be particular existing flows that you've already created with current transports that may also be event-driven that you would also want to expose as MCP tools. This is a harder job to achieve this because they're not necessarily structured in the way that an API or an MCP interface would naturally be. So that's the reason why it appears last in our kind of headlines for what we might head for, but lots more exciting things to come in the area of MCP. Given that background, we've got a demonstration that we'll be going to in just a moment. And this chooses to tie together both of those new features. So we have the exposure of connectors using an MCP tool that's defined inside ACE in containers. And in our example today, we're going to be using Salesforce and Slack as examples of two back-end applications. And then we'll also be connecting up to an MCP server exposed from ACE software. And there we'll be using two existing REST APIs, which have been deployed before the scenario kicks in. Across each of those environments, we're going to be playing around with some somewhat fictitious characters. So I'm a big football fan, so we're going to be talking today about Harry Kane, Gary Lineker, and Jimmy Greaves. And this is just giving us the opportunity to have three different people who exist inside Salesforce. We can gather back their information, and then we can use that info when we interact with the other services, with the other REST APIs. So this is going to be our demonstration. The next voice you'll hear will still be me, but on the pre-recording. And we're going to look through the invocation of these two different types of MCP servers using IBM Bob technology, which is a new AI capability that we have from IBM that's recently been brought to market. We've been trailing it for some time, and you can think of that as providing you a chat interface that provides an LLM, enabling you to invoke other kinds of tool. So Aditi, when you're ready, if you could queue up the video, that would be fantastic. We'll watch demo 1. This demo starts inside the App Connect container dashboard, where there's a new menu option on the left side called MCP servers. We're going to create a new MCP server from scratch, based on ACE's huge catalogue of built-in connectors for third-party apps. We provide a name for the MCP server, and we stick with the other defaults for the license and the version of ACE. We've sped up the next part of the recording, as typically this next step might take a couple of moments. When the page loads, there's a huge catalogue of built-in connectors listed alphabetically. In this example, we're going to pick a couple of different apps, Slack and Salesforce. It's worth noting that I'm not having to engage with any kind of flow experience in this example that historically you might expect to see with an integration product. Instead, I'm just simply choosing which of these apps I want to connect to and providing some security details, such as the access token for Slack. Next up, we have the Salesforce option, which requires a bunch of OAuth details, such as a client ID, client secret, username and password. In the interests of time and through the magic of a recording, we don't have to wait and watch those values being copied into the blank spaces in the wizard. On clicking the Connect button, we're going to go off to Salesforce, check those credentials are successful, and when they are, we'll see the pop-up in the top right corner of the wizard. Now if we scroll back up to the top of the dialog page, you'll see that we've got an account that's been created using our security credentials, and there's a wide number of different objects and actions that are available within Salesforce, which we can expose as MCP tools. We'll expand Contacts and choose the Retrieve action. The numbers in the blue balloon shapes show how many MCP tools we're due to create. In the case of Slack, we'll select the option to retrieve a list of available public channels and the option to send a message to a channel. So in total, the final summary page is going to show us we've got 3 separate MCP tools exposed from 2 different back-end applications, Salesforce and Slack. When we hit the Create MCP Server button to finalize the wizard, the process of spinning up that integration runtime again can take a couple of moments, hence the warning in the wizard. So having completed that process, we can now see a tile representing the MCP server on the dashboard. Drilling down into the server, we can see the information telling us how to connect to the server, which we'll use in a couple of moments when using IBM Bob to invoke the ACE MCP server's tools that we've just created. On the other tab, we see a summary listing the exposed tools. The next stage of our demo switches to a similar looking web browser experience, except this is the web UI for the ACE software product, not in containers. There are 3 servers and one of those already has 3 deployed REST APIs. Let's look at the customer API and try out the Get Customers operation. The API response shows 3 customers who happen to share their names with 3 English footballers, Harry Kane, Gary Lineker and Jimmy Greaves. The JSON data gives basic name, address and telephone information. Next, we're going to navigate back up the hierarchy and return to the integration server level for server 1, and then go into the loyalty card API, where we'll find another operation to get loyalty cards. The response message shows that there are only 2 customers who have loyalty cards. The info shows their home store, membership tier and the number of points they have. Now we're going to take those REST APIs and expose them as MCP tools using an experience that will be reminiscent of the wizard we saw a moment ago. We're going to choose server 1, which hosts the REST APIs that we were just testing. We can choose the port number that the MCP server will expose, and then the next panel allows me to expand the available APIs and select some operations. I'm going to choose the 2 GET operations in the customer API, and then I'm going to choose the 2 GET operations in the loyalty card API. And again, you can see as I'm making these selections, the blue bubbles update with the numbers indicating those selections. We have some finally summary information and then click the Create button. Next, we're going to switch to VS Code, where we'll use IBM Bob to invoke the MCP tools. To save time, we've already configured Bob's MCP settings JSON file, but I display it here to prove that Bob has already been given connection details. Switching our attention to the IBM Bob chat interface and making it full screen, my first question to Bob is to ask him to list the MCP tools. Bob checks the configuration JSON file and makes queries to the 2 MCP servers and returns a detailed description of the 7 MCP tools that are available.
4 from the on-premise ACE environment, and 3 from the ACE container environment. The next query we type in asks Bob to please retrieve the Salesforce contact with last name Kane. Bob already has the MCP tool context and knows the available tools, so there's no need for me to even mention MCP as part of this query. I also don't have to mention anything about ACE or have any knowledge of the underpinning infrastructure which is used to answer the question. The query goes through the MCP server and through ACE and gathers back a bunch of information about Harry Kane, including his date of birth, address, and a description. Next, we're going to repeat a similar query to find out about Jimmy Greaves. Again, the reply is laid out nicely once it completes here with about 10 bullets providing information from Salesforce all about Jimmy. You probably guessed what's going to come next. A final query of this type is going to retrieve information about our third footballer, Gary Lineker. Hitting on Approve makes the query go through, and we can see the response data has also come back successfully. Bob is now going to use the ID field from the Salesforce system to answer some more questions. For each of the retrieved contacts, find out if they're supermarket customers. In this example, the same IDs are actually used by both systems, but there are more complex cases where Bob can sometimes independently figure out the relationship between the taxonomy of different ID structures based on error responses or through further user interaction. In a similar fashion, Bob is now challenged to find out which of our 3 footballers have loyalty cards at the supermarket. This time the 3 replies give back slightly different responses. Harry Kane has a loyalty card, but the second query shows that Jimmy Greaves does not, and thirdly, Gary does have a loyalty card. And having received back that third response, Bob then takes all of the data that he's just retrieved and summarizes it together in a nice message that's been formatted and includes some icons showing ticks and a cross for the positive and negative responses. Our last task is to get Bob to summarize all the information in Slack. So we've begun by asking him to retrieve all of the Slack public channels so that we can figure out how to send a message to the general channel. The responses come back with the internal IDs and the human readable names of each channel. Checking inside Slack, we can see that there's currently no message there, and now we're going to ask Bob to send one through. Please send a detailed message to the general Slack channel summarizing everything you know about the 3 Salesforce contacts. So we're referring to the general channel in an easy human way without the need for those internal horrible IDs. We can see in the background Bob is generating quite a detailed summary message, which has got various icons inside of it, and then on clicking the Approve button once more, under the covers that will send the data off to Slack. Having seen the task completion dialog, we'll switch our focus to the Slack window and then look through the data that has just been sent across. You can see if we scroll up that there is information about each of the 3 contacts. We have some nice icons there to demonstrate their information, show whether they're customers at the supermarket, and also their loyalty card status. So this concludes our demo showing MCP tool exposure from both ACE in containers and traditional ACE software.
Okay, fantastic. Welcome back, everybody. I hope everyone enjoyed hearing about model context protocol servers, and in particular, Harry, Gary, and Jimmy. Try saying that after you've had a couple of drinks. We'll be returning to those characters a little bit later on when we do one of the other demos. Can't help but stick with my football analogies. Okay, so that's enough on MCP for today. We're going to move on to a different topic now, which is all about the support that ACE has for Java 17 integration servers. As some folks may be aware, when ACE 13 first came to market at the end of 2024, we really sort of started bridging the gap between 2 different Java releases. So Java 17 is the default JRE version with ACE 13, but we still also support Java 1.8. So if you'd like to stage your migration and adoption of the later version of Java, you can do that with ACE 13. However, that is for a limited time. So you can see there's a blog mentioned on the chart here, which gives a lot more detail about the various different areas that Java touches within the product. And there is also an important deadline looming. March 2027 will be the timing of our last release that will include still Java 8 as part of the ACE 13 release. We are working towards getting everybody onto Java 17. It's already the default. And as you can see with the diagram shown on the right-hand side, the vast majority of ACE 13 features run already under Java 17. Row 25 in that list is the support for WS security using X509 certificates and username tokens. And this arrived with ACE 13070, which is what we'll be talking about just now. So that's the next topic that we'll cover here. So against that backdrop of Java 17 support, what particularly have we done in the area of WS security? Well, for many years, ACE has actually included particular libraries and runtime capabilities of the WebSphere application server products embedded directly inside ACE. And so the Java 1.8 SOAP stack that you can see listed here is still available. It's still there as part of the product. And it's nowadays only loaded up by integration servers who are using Java 1.8. As part of that stack, you've not only got access to, but you've got some additional libraries that were WAS specific, and also quite an older version there, Jakarta EE version 8. And that version obviously predates some quite invasive changes that came when Java decided to start adopting more modern Jakarta standards. And as part of that, we've moved that namespace to now use Jakarta. That has had several implications for ACE inside of the product, how ACE operates. And some of those touch the user slightly. So sort of, for example, in the area of using JAX-B support within a Java compute node, or if you have your own Java code that you run as part of a Java compute node, that needs to work with Java 17 if you're going to adopt that newer version. Specifically where SOAP is concerned, we've actually got a new SOAP stack that we load up for those Java 17 integration servers, and that actually includes open source Apache Axis version 2, and also includes Apache Rampart. In many ways, this is kind of irrelevant as a user, but I know that many of our existing users like to know the technology that's under the covers. And particularly in the case of WS security, there may be folks out there who would like to exploit their existing Apache Rampart WS security policies. And that fits quite nicely into the user experience that we have these days. So the little picture that I've got shown on the right-hand side of this chart shows the fact that we have some policies in ACE that describe how a message flow should achieve meeting the WS security standard. And we're going to dive into that in quite some detail in the demo that follows. So I'm not going to go into more information here, other than to say, when you go through that experience that you'll see in the video, we have now both the existing policy sets and bindings approach that you may be familiar with from earlier releases, still reflected in the user experience, but we've also brought that bang up to date by incorporating it directly into our policy editor. So we'll see that when we generate some of these policy XML files. So with that in mind, what we're going to see in the demonstration is an example of using WS security with Java 17 integration servers. We're going to see both sides of that puzzle as well. We're going to see a consumer and a provider. So with that in mind, you're going to see a bunch of different pictures and some examples flowing through in the next video. So Aditi, when you're ready, could we play demo 2, please?
This demo shows how you can now use an integration server running Java 17 to host flows that can read and write SOAP messages secured using the WS security standard. The Oasis Web Services security spec provides mechanisms to help web service developers secure SOAP messages. In summary, it describes 3 ways for securing web services at the message level: authentication, integrity, and confidentiality. Authentication uses a security token inserted in the request message to validate a user and determine whether a connecting client is valid in a particular context. ACE 13070 supports 2 types of security token for authentication: username tokens and X509 certificates. Integrity uses an XML digital signature to help the server protect itself, and confidentiality uses message encryption, so that only services with the appropriate key can decrypt and read the data. We'll dive into the actual message flows using the toolkit in just a moment, but first let's use this picture to orient ourselves. In our demo, we've chosen to deploy an ACE Web Service consumer to one integration server and a provider to a separate Java 17 integration server. Each of these servers uses a separate external directory vault to host the credentials which are needed to access its own key store and trust store and to sign and encrypt messages. Each integration server has also been configured with its own JKS key store, which are represented by the orange boxes in the center of the screen. Each integration server has also been configured with its own JKS trust store, which are represented by the yellow boxes in the center of the picture. This example uses X509 self-signed certificates which we've already created and populated inside the key store and trust store belonging to the consumer and inside the key store and trust store belonging to the provider. Typically, configuring a public key infrastructure like this can sometimes be a bit tricky, but it doesn't make for a particularly entertaining demo, so we'll briefly share on the screen the various commands that were used in case you want to pause or revisit the recording later. We'll now take a brief overview of the message flows. Starting with the WS consumer, we have a SOAP request node who's already been configured with a WSDL file. On the HTTP transport tab, we can see the URL that we are going to invoke, secured via HTTPS. Switching to the WS Extensions tab, we can see the relationship with the WS Security policy, called Demo Consumer, that lives inside the Demo Consumer Policies project. Exploring the provider message flow, on the HTTP Transport tab, we can see the path suffix URL. We can also see that Use HTTPS has been ticked, and there's a similar relationship, this time with the Demo Provider policy. We'll go back to the toolkit to play some data through in just a moment, but looking in more detail about how WS security is applied, there are essentially 4 steps involved. Number 1, the consumer encrypts the data using the provider's public certificate and signs the data using the consumer's private key. Next, in stage 2, when the data arrives at the provider, it decrypts the data using the provider's private key and verifies the data signature using the consumer's public key. After the flow has done its processing, which in our example involves converting a temperature between Celsius and Fahrenheit, similar steps happen in reverse for the return leg. In stage 3, the provider encrypts the reply data using the consumer's public certificate and signs the data using the provider's private key. In stage 4, when the data arrives back at the consumer, it decrypts the data using the consumer's private key and verifies the data signature using the provider's public key. We're now going to take a look at the policy configurations that are associated with the 2 message flows. The Demo Consumer Policy XML file has 4 separate twisty sections of properties, one related to signing, another for encryption, and then the same thing for the opposite direction of data flow. Clicking the Configure button displays a dialog that will be familiar to ACE users from previous versions of the product. Now we have amalgamated the policy sets and bindings properties from earlier versions, this panel is required to list out the settings for message level protection and message part protection. We're choosing to encrypt and sign the whole message body, but if you wanted to do something more fine-grained with specific fields, the XPath expression page provides these options. Next, we'll switch our attention to take a look at the equivalent policy settings for the provider side of the relationship. The Demo Provider Policy XML file has a type of WS Security Input, and down below there are the same 4 sections that we saw just a moment ago relating to message signature validation and message decryption, and then for reply message signing and encryption in the opposite direction. The Configure panel launches the more detailed dialog with settings for message level protection and message part protection. The message part protection page is configured for full body protection, just like we had on the consumer side. Having gone through all the configuration of the flows, we'll now see them in action. We've already deployed both the consumer and the provider message flows, but we're going to use the flow exerciser and place the consumer into recording mode in order to track the data as it flows through the scenario. The security provider message flow has already been deployed, but it's currently in a stopped state. And before we use that, we're going to use an alternate flow that I've named Simple SOAP Sniffer, which has a SOAP input node, and we'll also place that into the provider integration server, and we will put that one into recording mode as well. The purpose of this message flow is just to capture the headers that flow through from the consumer so that we can look at them in a nice, easy fashion. Sending in the data with a temperature of 0 and expecting that to be converted, we will then exit from the message injection dialog and go take a look at what's happened. We can see the data made it as far as the SOAP request node, which invoked the sniffer flow, where we can go look at the data that arrived. If we go full screen, we can then see that from the context section, this SOAP input is in gateway mode. The header carries a WSSE:"security header. Collapsing the header, we can also see the body of the SOAP message contained the encrypted data and also some cipher data at the end of the message. Examining the WSSE security header close up, we can see lots of details about the binary security token and the encrypted key. Remember, this sniffer message flow does not have any association with the WS security policy projects that we defined, and in gateway mode it has made no attempt to decrypt any of these values. Looking at this detail gives us confidence that all of our hard work configuring the flows has paid off and the payload has been correctly secured according to our wishes. In the toolkit, you can see that we've now stopped the simple SOAP sniffer flow and we're starting up the WS security provider flow. Placing this into recording mode on the demo WS provider integration server will enable us to track the real data as it goes between the consumer and now the proper provider. Returning back to the consumer flow, we'll click the Send Message button and send the same data in that we were using a moment ago with the sniffer. And this time you can see we've received back an HTTP reply message which has converted the temperature into Fahrenheit. We can see there 32 degrees in the response data, which is an excellent sign. We can then go and look at the path that the message has taken and see it went all the way through the flow. And looking at the demo WS security provider flow, tracing the path that the data took, we can then see that once all of the encryption has been dealt with and the decryption has been dealt with, we have a standard form of SOAP body with the temperature being carried back and then placed into the response message in readiness for the SOAP reply with the converted temperature. And so this concludes our demonstration of WS security in Java 17 integration servers.
Okay, so that was all about WS security using X509 certificates. We're expecting to add support for using SAML tokens and Kerberos as part of our next release, so I'm sure that's a topic that we will return to in the future. But for now, let us move swiftly on. Plenty more topics still to get through today. So the next thing we're going to talk about is somewhat similar to WS security, but a different web service standard, WS reliable messaging. We also support WS reliable messaging with the 1307 release in a Java 17 integration server. And again, we've made some slight changes to the configuration of this particular feature compared to earlier ACE releases that provided it within Java 1.8. As part of the redesign here, we've essentially enabled a policy to abstract that away from the message flow node properties. So on the SOAP request node that you can see at the base of the chart here, you have a reference to a WS reliable messaging policy. It's entirely optional. You don't have to use the feature. And then inside that new policy type, you can see there's a variety of parameters, including whether or not you'd like to do in-order delivery, whether you want to use WS make connection. There's a bunch of other settings that are provided there. So WS reliable messaging, no video of that one today. We felt that was maybe a little less worthy of attention than WS security, given the complexity that we've just seen in the demo. But yeah, that one's there available now and ready inside Java 17 as well. So leaving the arena of web services to one side, the next topic we're going to talk about is batch processing. For a long time, people have done batch processing with ACE, but they've had to do that certainly within Toolkit flows using a somewhat convoluted method where you might choose to propagate workload either through an external queue or a Kafka topic in order to get multi-threaded and running, or alternatively, maybe just using the propagate statement within a while loop of a compute node to fan out the thread in multiple different actions that you might want to achieve. But what we've got here is a feature that applies this to the masses. With the designer authoring tool, you can basically insert what we call as a batch process in the middle of an event-driven flow or inside a flow for an API. So regardless of the way in which you're triggering the message flow, you've then got this batch process that's shown in the major red box on the chart here. Now, within the batch process, you've got the concept of choosing the section of data that you'd like to iterate over as part of the batch. So in an example in the moment, we're going to be using Salesforce in order to provide that input. And then within the batch process itself, you'll see I've got a little sort of double-headed red arrow here, which is showing there's the section of the message flow over which we essentially propagate the batch information that's come in one record at a time. And in this way, we can work our way asynchronously through a large data set or a query that's returned to us lots of records and then repeat that logic for each one of those records. As the batch is going along, you can actually pause it, you can stop it, you could resume it. We've got a nice little status page that shows what's happening with the batch. And it also gives us the opportunity to work in tandem with some other persistence mechanisms as well that we'll talk about in due course. But if we first of all just introduce the idea of the designer batch processing flow itself, what we're going to see is a slightly shorter demo coming next. This one is going to talk us through a scenario that involves going off to Salesforce, gathering back a set of records, and then dealing with them as a batch. And we're going to see that batch in flight as it operates. So Aditi, when you are ready, if you could launch us, please, into demo number 3.
This demo shows the new batch process action in Designer that can go in an event-driven flow or in a REST API. Our scenario is triggered by a scheduler node, and then ACE retrieves a set of contacts from Salesforce. This data set is passed into the batch process, which runs asynchronous to the main part of the flow. In our scenario, we're going to use a Slack node to send a message indicating that the batch has started. The batch process iterates over the retrieved contacts, and for each one invokes a REST API to find out if the contact is a customer of a supermarket. For convenience, we're actually using a REST API hosted inside ACE. This isn't particularly relevant, but lets us closely control how fast the API responds to help make this demo a perfect length. Info about each contact is then written to a separate message on a queue. Then at the end of the flow, we write another message to Slack summarizing the results of the whole batch. Here in Designer, we'll quickly examine the properties of each node in the flow. The scheduler fires once a day at midnight, and also when the flow is first switched on, which avoids us having to wait for the batch to get triggered. Before diving into the batch process part of the flow, which queries Salesforce, we'll next take a look at the Slack node, which will send a message to the general channel. The message text states that the batch process has been started and includes a timestamp with the current event time. The batch process section of the flow starts with a Salesforce node that has been configured to retrieve contacts. There is no further qualifying where clause in this example. If you'd like to, you can restrict the maximum number of contacts to retrieve, and there's also an option for generating an ID for each record in the batch. Back in the flow, you'll see there's a couple of icons to mark the beginning and the end of a section of behavior where the fanned out records go through the REST API call and then the if statement. The REST API invocation passes the ID of the Salesforce contact into the REST API so we can find out whether this specific contact is a supermarket customer. The if block that comes next examines a code, which is a field in the API response data structure. If the code carries the value 999, then the MQ node that follows down the top branch will write info about the contact to a queue called sf.supermarket.notCustomer. Alternatively, if the return code from the API was not 999, then a matching supermarket customer record was found, and so the alternate branch of the if has an MQ node that writes to a different queue called sf supermarket customer. After the end of the batch process part of the flow, we use another if statement that checks whether the number of records that process successfully match the total number of records. This causes a log node to write that all messages were a success. Down the other branch, we log that all messages were not processed correctly. At the very end of the flow, the second Slack node writes a summary message that also includes a log of the current time. Next, we'll rearrange the screen in readiness for running a batch of data through the message flow. Rearranging our windows, you'll note that there is a green screen and a blue screen, and these will be used to drain messages from the two output queues. We can see that to start with, there are no messages in Slack. In Designer, we select the option to test with real data, and then immediately following we'll choose to view the batch so that we can keep track of its status as it progresses. In the green window, we'll start the AMQS GET application running, and you can see we've already processed a few contacts who are not supermarket customers. In the blue window, we'll set off the same command looking at the other queue. We haven't reached any contacts who are customers just yet. Let's refresh on the batch status to see how we're doing. We were on 13 and now we've completed 14 of the 24 contacts. In the blue window, the app times out if no messages have been written for a few seconds, so we'll just run that command again. We've now hit some contacts who are supermarket customers. In total, we're expecting 3 of the 24 contacts who all share their names with famous ex-footballers for my team Tottenham Hotspur. All 24 contacts from Salesforce have now been processed, and we have 21 in the green window and 3 in the blue window. Next, we'll go back to the Slack application to check on the output there, and sure enough, we can see that final summary message. The last thing that we'll do is to go take a look at some logs. There's a handy link from the status view that filters the logs using the name of the message flow. There's an entry showing the write to Slack, and if we scroll on further down, there are also some examples of writing to the MQQ for those who are not customers, and also the MQQ for those who are Salesforce customers. And so, in conclusion, we've seen the new batch process option in Designer in action, processing a set of retrieved contacts from Salesforce.
Okay, so that was all about Designer batch processing flows. We've got one more demonstration to cram in today, and before that, a few quick fire topics. So, as usual with ACE, we always are keen to introduce new connectors that can talk to third-party systems. This release is no exception. 13070 has several both input and request nodes. You can see them at the base of the chart here across 5 different third-party systems that we've not supported previously. So we've got a mixture of Google Analytics, AI platforms, DevOps tools. Hopefully it's something for everybody in the offering here. And we're going to continue adding new AI capabilities that can be invoked within the middle of a message flow. And of course, if there is any big system out there that there's a demand for, we would always look to come and revisit that and add things in. As usual, we're also expanding the number of authentication types that we have as well. So if there's an existing object or action that you'd like to see us add to one of our connectors, please do get in touch and we can always increment the product in that area. We don't have the time to go through all of those connectors today. So rather than do any further demonstrations there, we'll move right along and just quickly mention event resilience policies. Event resilience policies really come to the fore in areas where we need to persist data after it's been queried from a back-end system. Now, if we think about that batch processing that we were just looking at and the ability to span that workload, potentially over multiple replicas in some sort of situations where containers are concerned, in these situations, it would be helpful to us as an architecture to be able to store away that data after it's been gathered in, but before we've then processed it. So if we think about how that actually happens within our tool, we've already got this capability of using an in-memory queue to store the records that have been queried before we then fan that workload out into the various parts of the diagram that we were seeing a moment ago with batch processing. So that's the event resilience policies. You can configure that. At the moment, it's just around a type of Kafka. But again, other transports are available and we may come to those in due course. The next demonstration topic requires a couple of charts for us to set it up. And this is a design pattern that we call claim check. And it's offering the ability to quickly transfer large pieces of data between 2 different third-party applications. And in these kind of situations, it's often worthwhile from an ACE architecture point of view to not have to carry all of that data on a message flow thread in the middle of a message flow. Maybe we want to retrieve a large amount of data and then pass it on to another app without touching the flow itself. If we think about it, an analogy here is like when you deliver your luggage to an airport and you check your luggage in at the check-in desk and you're given this little token that you can essentially use to prove that the luggage is yours when you get to your destination, or as we sometimes call it in the claim check design pattern, redeeming your token in order to make sure you then get the message payload back again. And that's exactly the concept that we have here. And we've offered this to begin with for a subset of our connectors. You can see them listed at the bottom of the chart. And these are the ones that are capable of essentially streaming data and then passing on that data in smaller chunks to a different connector. So if we think about what that actually looks like inside of a message flow, in my pseudo flow here, I've got multiple nodes. And you can see there's a couple of endpoint systems being integrated here between point 2 and point 3 in the flow. We're doing a query to an endpoint system in yellow, and then the little grey structure that gets passed in memory to node number 3, that's essentially a reference that node 3 can use to go grab the data from the yellow system and then push it into the blue system and then get a response back again that gets passed into the message flow itself, into that logical tree, as would normally happen with any of our connectors. So without further ado, we're going to crack on and see a demonstration of the claim check design pattern using a couple of Discovery Connector request nodes. And then we'll just about have time to round up with maybe a couple of questions and one final topic that I'll talk about when it comes back to me. So Aditi, if we could show demo 4 for claim check when you're ready, that would be fantastic.
This demo shows the new claim check feature in ACE, which efficiently transfers large payloads of data between apps without incurring a large memory overhead in the flow itself. We'll be using files in Dropbox and Salesforce, and as you can see, I've already created credentials for those apps in my server's external directory vault. We'll be using the message flow shown, which receives JSON data over HTTP. The inbound message will match to the highlighted JSON schema and will include a path to the file that we want to retrieve from Dropbox. The flow order node routes first to an HTTP reply and then invokes the Dropbox request node. Next, we'll jump into Connector Discovery to look at the configuration of the download file action in a bit more detail. As usual, we have a policy project used by the Connector Discovery process, and after a few seconds loading, we're going to look at the response controls. That includes a property for defining the way in which the node should handle binary response data. You can choose between the JSON domain or the blob domain for this property. The main action of the node has already been set up to download file. Returning back to the message flow view, the trace node comes next, which is configured to write to a file the current timestamp, and then the context reference function is used to display the in-memory tree that has been output by the HTTP input at the start of the flow, and then the output from the Dropbox node. This will let us demonstrate that a claim check token is passed from the Dropbox node to the Salesforce node, avoiding the actual file content coming into the flow. The last node in the flow is the Salesforce request. The map shows that the Salesforce file content has been assigned directly from the file content structure that came out of Dropbox. The title property is used to name the file and is calculated using the substring function, which takes the file name characters from the end of the path property, which arrived as part of the initial JSON input message. We're starting from an empty integration server, so next we'll deploy the claim check policy project by dragging and dropping it onto the test server. Next, we drag and drop deploy the claim check application itself, which has the message flow inside of it. In order to test out the flow, we'll rearrange our windows to show the available files currently preloaded inside Dropbox in the browser window on the middle left of the screen. The bigger Salesforce browser window on the right shows there are currently no files owned by me in the Salesforce platform. We'll use the command console at the top of the screen to invoke the message flow using curl. The input data carries the path to a PowerPoint file named pres_approx1mb. Our trace file has been written to disk, and refreshing the Salesforce view shows the file has been successfully retrieved and copied over. We've now repeated the command for transferring a second PowerPoint file, this time it's 5 megabytes in size, and finally we run the command for a third time with a 10 megabyte file. Now we've moved 3 files, let's examine the content of the generated trace file, which has 3 sections of data, each with timestamps matching what we've just run through the system. You can see there is a file content item in the tree with a new type called claim check. For informational purposes, the text tells the user that the token originated from Dropbox. This is handy in more complex flow situations where you might have multiple claim check tokens being passed around. Back in Salesforce, we can select the 1 megabyte file and Salesforce will preview the contents after a few seconds. Having proven that the flow worked successfully, we're now going to delete the 3 files from Salesforce. For this demo, I'm working in a developer edition account, which constrains me to a maximum total of 20 megabytes of storage space for files. In a moment, we're going to try out some bigger files, and I want to avoid potential errors from Salesforce by going over the limit. So let's clear down the 1, 5 and 10 megabyte files. For this last section of the demo, I'm going to bring up Windows PowerShell, where I can loop around the get process command every second and report on the working set memory being used by the integration server process. I'm going to leave that running while we go back to the command console window at the top of the screen and send in a new request to retrieve the next file size, which is a size of 20 megabytes. I'm then immediately going to repeat the curl command and send in a 50 megabyte file as well. and although this will push me over the Salesforce file limit, it's normally gracious enough to give me one last file as I blow through the limit, especially if it's in quick succession. If we refresh the browser, after a couple of seconds we should see both files have appeared. Taking a look back at PowerShell then shows the memory of the server has only increased very slightly and nowhere near the size of the files that have been successfully streamed directly between Dropbox and Salesforce. So in summary, we've seen the new ACE claim check feature that efficiently transfers large data payloads directly between applications.
Excellent. So that was all about claim check. So hopefully that's relevant to a lot of folks. I can certainly see from some of the questions that have been flying through, there is definitely interest in asynchronous processing and the ability to process large payloads. So I think that one should have hit home quite well. We've just got one last chart to cover today before I'll go over a couple of the questions that have arrived in chat. And that's on the subject of Kafka OAuth bearer tokens. A few folks have actually been asking about OAuth today. So we see increasingly the OAuth security model being important to the way that not just connectors operate, but also raw protocols integrate between different servers as well. As folks may well be aware, the purpose here with OAuth is to avoid a user having to use their own direct user ID and password in all kinds of security invocations. You can see a diagram in the bottom right corner that marks out some of the different roles that are at play here. In many of these cases, ACE itself is actually acting as both a client potentially, but also as a resource server, and in some extreme cases, also an auth server as well. In this particular one, ACE is providing the ability of being essentially a resource server. So a user here, a client application, is communicating with an authentication server to provide them a token. And then that access token that's returned to them can then be presented to ACE and then validated by ACE in order to ensure whether or not we should respond to the request. So you can see that that's caused us to have to introduce a couple of new properties. We've got an OAuth 2 token endpoint URL and the various other items that have been added in red there that may already be familiar to Kafka users who've used Kafka outside of the ACE product. So this is a new security mechanism that's provided there. It's very logical for us to place that onto the policy and avoids you having to do anything further on the message flow node itself. So that should be nice and isolated and lines up in a very similar fashion with other transports. You'll notice that we've got a Kafka credential that's shown in the top right corner, where we've got the authentication types of client and client scopes that have been laid out there. So all very natural. Hopefully that fits in nicely with the use of OAuth 2 in other circumstances. Drawing towards the top of the hour here, we've got a couple of moments left. I will just use those to respond to a couple of the questions that I've not had time to type answers to. Somebody has asked about the exploitation of OAuth 2 regarding SharePoint connectors. So I mentioned earlier, we're always looking to revisit the auth capabilities. I'm not enough of an expert on SharePoint to know whether that one's there already. So I might have to go and do some homework on that one for Peter. But yeah, if it's not there already, then certainly we would look into that. We're seeing OAuth 2, as I say, get increasingly popular. So we've added that around the area of HTTP and REST services in prior releases. Now we've come to add that to Kafka as well. And many of the built-in connectors already followed that OAuth model. Similar kind of question, somebody has asked about whether or not OAuth 2 works in Toolkit as well as in Designer. Yes, it does. So when we implemented the OAuth capabilities, and we were ensuring to put those into the runtime so they could be exploited by both Designer flows and Toolkit flows. So on an earlier webcast that I've done, we talked through that capability with REST APIs in particular. So yeah, good news on that one. Somebody else has asked about introductory material. I sometimes forget about our newer users on calls like this one, so apologies if we've gone too high, too low level on this one today. There are lots of docs out there. In particular, also take a look at the tutorials. Inside the ACE Toolkit, there's some great tutorials that step through these subjects for the first time. So definitely check that one out. Voice giving up right at the very end of the call. We've got one other topic which has come up through the questions, and that's about S3 connectors. So it says, usually connectors need connectivity from Toolkit to S3 to get buckets, but this might not be possible. Is there an alternate? I'm not quite sure which particular alternative you were thinking about there, but in general, the Toolkit and the Designer both offer the same kind of connector groupings that we have. So certainly the S3 connector is available in both those situations. So I'm not sure if I've missed the point on that one, but yeah, absolutely. S3 very much part of what we do, can be used from Toolkit as well. Somebody else has asked a question about pricing. I'm not sure there's a lot I can do about that one, but I will pass that on to my product management colleagues. Hopefully you get good value regardless of the cost of the ACE product. And the last one is about the recording. And yes, absolutely, you'll be able to access the recording through the standard IBM community website. It's through the same registration link that you already have followed to get here today. So if you're listening to this, yes, you can go back through that link when the recording's available and take another second look. Any problems with that, then feel free to ping me directly. We often put up the responses of these kind of demos onto YouTube as well. We've got a channel to put those up in due course as well. With that, we've got almost the top of the hour, so we'll finish a couple of minutes early today. Nothing else for me to say other than thank you very much for your attendance and your continuing interest in ACE. It's very much appreciated. So thank you for joining, and hopefully see you next time along, where we'll be talking about next quarter's content. But for the interim, have a great day. Thank you very much.